Hi students, problem number 5 in the exercise. The reading of pressure meter attached with a closed pipe is 5 into 10 power 5 Newton per meter square. On opening the valve of the pipe, the reading of the pressure meter is 4.5 into 10 power 5 Newton per meter square. Calculate the speed of the water flowing in the pipe. So very simple problem, but very important for your board examination. Now this is based on Bernoulli's theorem. Understand? Now I have written whatever is given in the numerical problem. Initially when the valve is closed, so for the closed pipe, the initial pressure is taken as P1. That is given as 5 into 10 power 5 Newton per meter square. Since the pipe is closed, initially there is no flow of water. So the initial velocity of water can be taken as 0. Next, for the open pipe, the pressure meter's reading is given as P2. So P2 is equal to 4.5 into 10 power 5 Newton per meter square. And with what velocity the water is going to flow when the pipe is opened. Now here it is to be understood that the pipe is a horizontal pipe which is at the same level or height from the ground level. So here H1 is equal to H2 is equal to H. So I can write here H1 is equal to H2 is equal to H. So from Bernoulli's theorem, so we have studied Bernoulli's principle. So from Bernoulli's theorem, the total energy per unit mass remains constant, is it not? So P by rho plus V square by 2 is equal to constant. Okay. So P by rho, pressure energy per unit mass, V square by 2 is kinetic energy per unit mass, and potential energy on both sides it get cancelled because the height of the tube is a constant. Now this also can be written as what? P1 by rho plus V1 square by 2 is equal to P2 by rho plus V2 square by 2. Now I am going to multiply all these four terms on both sides by the density of water, that is rho. So when I multiply this first term by rho, it becomes what? P1 plus the second term will become rho by 2 into V1 square. So this is equal to P2 plus rho by 2 into V2 square. Now this term V1 square is 0 because the water is initially at rest inside a closed pipe. So the above equation becomes P1 minus P2. P1 minus P2 is equal to rho by 2 into V2 square. Okay. Rho for water is how much? Density of water is 1000 kg per meter cube. I am going to substitute rho equal to 1000. And P1 and P2 values are given here. So 5 into 10 power 5 minus 4.5 into 10 power minus 5. So I can write 5 minus 4.5 into 10 power 5 on the left hand side. Common factor is 10 power 5. And this is rho by 2. This is 1000 by 2 into V2 square. So left hand side 5 minus 4.5, that is 0.5 into 10 power 5. Okay. This is equal to 500. 1000 by 2 is 500 into V2 square. Now this 0.5 into 10 power 5 also can be written as 5 into 10 power 4. So this is 5 into 10 power 4 is equal to 5 into 10 power 2. 500 also can be written like this into V2 square. So these 5 and 5 get cancelled. Therefore, V2 square is 10 power 4 by 10 power 2. So V2 square is equal to 10 power 4 by 10 power 2. So this is equal to 10 power 2, that is equal to 100. Therefore, V2 is equal to square root of 100, that is equal to 10. Therefore, V2 is equal to 10 meters per second. Okay. So this is based on Bernoulli's theorem. We started with the general equation. Here the third term is missing because of the height, horizontal pipe. Same height on both the ends. Therefore, P by rho plus V square by 2 is equal to constant. Then we multiplied by rho on both sides. Where rho is the density of water. And we got the value for velocity V2 is equal to 10 meters per second. I hope you must have understood that fine.